In today's lesson, we will be finding the area of a parallelogram given its base and height, and we will also find the area of a trapezoid given its bases and height. And once again, we do have a couple of standards that we will be reviewing in this lesson. Our first one is 6G1, and then our second one is 6G3. All right. So here we have figure ABCD, and that is a parallelogram. And it's a parallelogram because it does have 4 sides, and opposite sides are parallel. And so you'll notice that if we take this little triangle section that's in the maroon, so this piece right here, and if we take that off and we move it to the other side of the parallelogram, you'll notice that we've now created a rectangle. And as we established yesterday, our area of a rectangle is area equals length times width. Well, that just so happens to be the same formula that we use to find the area of a parallelogram, except instead of saying length and width, we will say base and height. Excuse me. So in the figure ABCD, that is a parallelogram, and we know that segment BE is a straight line. So we again want to use base and height as our 2 dimensions that we use for area. So area equals base times height, same thing as length and width. So many times in a parallelogram we'll have multiple dimensions given, and we just need to make sure that we pick out the correct dimensions. And usually the easiest one to pick out is the base. So we're going to use the 8 as our base. And then the height, we have 2 choices. We can use the 5 or we can use the 4. And we choose our height the same way that we chose our height in the triangle. When you measure height, you need to go straight up and down. So in this case, we're going to use the 4 as our height. So we take 8 times 4 to give us 32 square centimeters. All right, at this time, pause the video, do these practice problems. When done, unpause the video and check your work. All right, so you should have done these next few practice problems here. If you haven't, make sure you pause when we get to them and make sure you do the work before we go over the solutions. So we want to find the area of these parallelograms, and we know that each square measures 1 unit by 1 unit. So just like when we were finding the area of triangles, we want to identify a base and a height. Excuse me. So generally it's best to use the bottom part as your base, or one that has that straight edge to it. So we're going to use this bottom part as our base, and that base is 1, 2, 3, 4 units. And then for our height, we do want to go straight up and down, so we can put in a height right here, and we can measure that height as 1, 2, 3, 4, 5, 6, 7. So we would take 4 times 7, which gives us 28 square units. For number 2, our base, 1, 2, 3. Our height, we're going to drop this down as our height, and our height is 1, 2, 3, 4, 5, 6, 7 again. So we would take 3 times 7, and we would get 21 square units. Okay. These 2 others you should have done as practice. If not, go ahead and pause now and work those 2, and then resume once you have them. And if you have them, here we go. So again, we need to identify a base and a height. So the base, we'll just use this bottom part again. 1, 2, 3, 4. Excuse me. Height. I'm going to drop that down. I went off a little bit, and that's okay. 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 8 for 32 square units. And number 4 here, we have a base of 2. Height, we're going to drop it straight down. And we have 1, 2, 3, 4, 5, 6, 7, 8. Imagine that. And we would take 2 times 8, and that would give us 16 square units. If you haven't done 5 or 6 yet, go ahead and pause, do those, and resume. If you've done them, here we go. So again, we want to identify a base and a height. So our base, we're going to use the 21 centimeters. Our height, remember for height, you want to be going straight up and down. So we're going to use 12 centimeters as our height. So you would take 21 times 12. 21 times 10 is 210. 21 times 2 is 42. So that would give you 252 square centimeters. For number 6, again, you want to identify a base and a height. So our base, we're going to use 24. And then our height, we can either use 15 or 14.5. 14.5 is the one that goes straight up and down. So we'll use that as our height. So you take 24 times 14.5. And again, if needed, if you have to do the work, that is perfectly fine. I'm going to need to do the work on this one, so I'll put it off to the side here. 4 times 5 is 20. 16 plus 2 is 18. 4 plus 1 is 5. Start with the 0. 5 times 2 is 10. 8, 9, 2. Add those together. 0, 8, 14, 3. 1 digit after the decimal point. So I'd have an area of 348 square inches. All right, our next figure is a trapezoid. Now you can see here that the trapezoid is created by putting 2 triangles together. And I could go into a whole long big spiel about how you would derive the area of a trapezoid, but for time's sake, I'm just going to go ahead and give you the formula for finding the area of a trapezoid. So area of a trapezoid is 1/2 base 1 plus base 2 times height. Excuse me. Okay. So in this particular case, your bases need to be opposite of each other. Okay, they have to be parallel. Okay, so one base would be down here, and this base would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The other base is going to be parallel to it and on the opposite side, and so that's going to be the section AE, 1, 2, 3, 4. Okay, so the area here would be 1/2 4 plus 11. Because base 1 is 4, base 2 is 11, or base 1 is 11, base 2 is 4, so you do 11 plus 4. Either way, doesn't matter. And then we're going to multiply that by the height, and again, the height goes straight up and down. We can find the height over here as 1, 2, 3, 4, or right here, 1, 2, 3, 4. Either way is fine. Okay, so that is our height. So if you follow your order of operations, it'll be 1/2 of 15 times 4. Now, all of this is multiplication. So all of this we can move around. So we could actually take 1/2 of 4, which would be 2, and 15 times 2 would be 30 square units. Excuse me. So here we have a trapezoid. we know that TW is parallel to UV, and we want to find the area of the trapezoid. So once again, we use our formula, area equals 1/2 base sub 1 plus base sub 2 times height. So I'm going to scroll this a little bit. We'd have 1/2. Base 1 is 12. Base 2 is 26. And our height would be 14. So we would have half of 38 times 14. I'm going to do half of 14 to get 7. So you'd have 38 times 7. 7 times 8 is 56. 7 times 3 is 21 plus 5 is 26. So that would be 266 square centimeters. And at this time, go ahead and pause the video, work these problems. When done, resume video, and we'll go over the work. All right, so you should have completed the sample problems here, finding the area for these trapezoids. Okay. So again, we do have to identify a base. Remember, our bases need to be opposite each other, and they need to be parallel. So we'll use this top part, 1, 2, 3. We'll use the bottom base, 1, 2, 3, 4, 5, 6, 7. So we've identified our bases. And then our heights, remember, we just want to go straight up and down. So we've got 1, 2, 3. So we would do 1/2 base plus base times height. So half of 10 times 3. Half of 10 is 5. 5 times 3 is 15 square units. For number 8, for our bases, we actually have to use the left and the right. We're not always going to be able to use the top and the bottom, but what we want to look for are those parallel sides. And so we have 1, 1, 2, 3, and then our height is 1, 2, 3, 4. So we would have half of 1 plus 3 times 4. So half of 4, excuse me, times 4. Let's be crazy here. Let's do half of 16, which is 8 square units. Number 9, we want to find the base. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And then the height. 1, 2, 3, 4, 5, 6, 7. So 1/2 of 4 plus 7 times 7. 7 plus 4 is 11. So we'd have 11 times 7. I would do 11 times 7 to get 77, because then that would give you 77 over 2, which is 38.5, or 38.5 square units. And finally, number 10, 1, 2, 3. 1, 2, 3, 4, 5. And then we need a height. 1, 2, 3, 4, 5, 6, 7. So 1/2, 3 plus 5 times 7. So half of 8 times 7. I wonder what I should do here. Maybe half of 8. Does that sound like a plan? So 4 times 7, just 28 square units. For number 11 and 12, if you haven't done those yet, go ahead and pause the video, work those, and then resume when ready to check. All right, so for number 11 here, we have our bases, and we have our height. So 1/2, 25 plus 13 times 39. So half of 38 times 39. So we need to do 19 times 39. 9 times 9 is 81. 9 times 7 is 27, plus 8 is 35. Second line with the 0. Excuse me, 9 and 3. Add those together, 1, 14. So we would have 741 square feet. Excuse me. Bases, height. So 1/2, 21 plus 10.6 times 13. So half of 31.6 times 13. I'm going to take half of 31.6. And if need be, remember half, you're just dividing by 2. So do our work here. So that would be 15.8. You're going to take 15.8 times 13. So I'm going to do that off to the side here. 24, 15, 17, 3, 4, 0, 8, 5, 1. Add those together, 4, 15, 10, 20. Let's move this guy out of the way. And we need 1-digit decimal point. So 205.4 square centimeters. And then finally today, you'll use that formula to try to find a missing dimension. So again, we're going back to that formula. Area equals 1/2 base sub 1 plus base sub 2 times height. So what we're given is we are given that the area of the trapezoid is 4,196.5 square meters. So I'm going to take out area and put in 4,196.5. I know I'm going to have the half. And then I do have my two bases, so 56 plus 98. And what I'm missing is the height. So now we're just going to solve the equation much like we did earlier this year. Okay. And again, there's a couple things you could do. You could start by multiplying both sides by 2, or we could do some work and then take half of whatever 56 plus 98 is. There are lots of options here. Okay. So I'm going to start by just following my order of operations, and I'm going to add 56 plus 98, and that would give me 154. Then I'm going to take half of 154, which is 77. And then, just like we did earlier this year, I'll divide both sides by 77. Now, I don't know what that is off the top of my head, so I'm going to have to do a little bit of work. So I'm going to scroll down here so I can give myself some room. So 77 goes into 4,196.5. Okay. Well, I know that 7 would go into 41 5 times. So I'm going to see what 77 times 5 is off to the side and see if that works. That looks good to me. So it's going to go in 5 times, 385. Do my subtraction. I get 34. Bring down the 6. Now, if I know that 77 times 5 is 385, this is just slightly less than 385. So I'm going to put that in for 4 times. Scroll down a little bit so I can have some more room. 4 times 7 is 28. 4 times 7 is 28 plus 2 is 30. So I do my subtraction there. I get 38. Hey, 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 look at that. It's 385. And I know that goes in 5 times. So my height is 54.5 meters. And again, this is just meters because it's just one dimension. It's not the area. Go ahead and pause the video here and find the height. All right, so once again, area equals 1/2 base sub 1, base sub 2 times height. So half of 38 plus 22 times height. I forgot to change my area, so I'll fix that real quick. 1, 2, 4, 8. Well, I know 38 plus 22 is 60. I know that half of 60 is 30. And so I just need to divide both sides by 30. So I'll do that off to the side here. 30 would go into 124 4 times. That's 120. Just 4, bring down the 8, goes into 48 once. That would give us 18. Now you could stop here. You could stop here, and you'd get 41 and 18/30ths, which is simplified down to 41 and 3/5. But I know some of you like to keep going, so you put a decimal point and a 0 on. Bring that 0 down. 5 and 30 goes into 186 times. So you could also have 41.6, and in both cases, that would be centimeters.